Okay, looking at section 9 for the chapter. One of the things that we need to try to remember is that when we're looking at this, we're talking about electron configurations. And just by the basis from what we see here, when we take a look at a couple of things, is like number one, this area here, the s orbital, is always going to be filled first because it's the one closest to the nucleus. Okay, so always try to remember that the first orbital we're always going to fill is going to be the 1s orbital because it's the one closest to the nucleus. It's the lowest energy, so it's always filled first. Now, when we go through this and we start looking at all of the items that we're going to be dealing with, a couple of things that we're going to deal with is something called a valence and electron. Now, when we're talking about this electron, this configuration and these orbitals and stuff like that, we're going to focus on the 8 electrons that are the outermost, or the location that can contain up to 8 of the electrons. So the outermost electrons, the 8 outermost electrons are called our valence electrons. They cover the outermost energy level, and these are the ones that interact with everything when we have a chemical reaction. So you can remember several chapters ago when we talked about, we balanced the charges of some atoms, and some atoms gave a charge, and some atoms took a charge. Well, these are the electrons that do that. Now, we're going to take a look at what's going on here. So let's start through this. So we're looking at the orbital electron configuration is given by the item here. That is your electron configuration. Now, so it's energy level 1. So that means that element must be on the top row. And it's an S, and it has 2 electrons. So this one has 1 electron. This one has 2 electrons. So therefore, we know that that's a hydrogen atom. Now we notice we're going to see this spin going on. So when we fill this up, we fill in 1. So if we had hydrogen only have 1 spin and it would be up. So hydrogen would have been 1. So when we move on, we take a look at this lithium. So the orbital diagram, lithium has an energy level 1 and an energy level 2. So that means it's on the second row. Now, let's count the electrons. It's got 2, 3. So 1, 2, 3. So there's our lithium. Okay? Its highest energy level is 2s1. So when we fill this in up here, we notice how we have one set of unpaired electrons. Okay? Because 1, 2, 3. Now, should have been one more here. That would have been 4. But we didn't have any. So let's take a look at the next one. Now, the oxygen atom is going to be a little bit different. Let's walk ourselves through it. So it's 1, energy level 1, energy level 2, energy level 2. So the highest energy level we see is a 2. So we know it's going to be in this second row. Okay? Now, we talk about this, and this is 2, 4, 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now that's pretty straightforward. We counted over to the 8th space, and there's our oxygen. It has electrons in the 1s shell, the 2s shell, and the 2p shell. Now, when we look at this, remember, P can handle up to 6 electrons, so it's got 3 boxes. 1, 2, 3. We fill the up ones first. 1 more 4 is down. This right here you got to pay attention to, so it's going to trick you up if you're not careful. So let's see what else we got going on. So when we talk about our first 18 elements, we can see how things go. Remember, counting the number of electrons, S contained 2. S can contain maximum of 2. P can contain a maximum of 6. Okay, so that's where we're at right now. Now, the core electrons are our inner electrons. The valence electrons are our outermost electrons, or the ones with the highest principal energy level. So we got to be careful on that. So when we talk about this, we want to make sure that we know what we're doing, okay? So the elements in this same group of the periodic table have the same valence electron configuration, meaning like 1s2, s2p, okay? Elements in the same valence electron arrangement have similar chemical behavior. That's important, okay? So I'm going to, when we take a look at that periodic table, oh boy, I can't draw today. So we have the periodic table that looks something like this, okay? Now what they're saying is that when we go straight down here, all of those elements kind of act the same. We watched a few videos a long time ago about that. All of these act the same. All of these. We go straight down. It's because they all contain the same number of valence electrons, okay guys? Because they have the same number of outer shells. This column here has 1. This column here has 2, 3, 4, 5, 6, 7, 8. Okay? So we just keep track of that. Now we're going to take a look at this guy. We're going to try to find cobalt here. And we're going to see if we can figure out how many unpaired electrons this element has. So this color here is an S block. And so an S block holds 2. This block here is called a P block, and it holds 6. Okay, so this one has 1 box. This one has 3. Okay, and cobalt is here. It's in the D block, and the D block can have 1, 2, 3, 5, 6, 7, 8, 9, 10. So that means it would have 5 boxes. 5 boxes. Man, 3, 4, 5. Okay, so 1, 2, 3, 4, 5, 6, 7. So I got to count over 7. So 1, 2. Oh, hang on here. 1, 2, 3, 4, 5, 6, 7. Now, so I have. So let's go to this next one. Can an electron in a phosphorus atom ever be in a 3D orbital? So let's find phosphorus up here. All right. So phosphorus is right there. Now the highest energy level it can have is a 3p, and we'll notice that it can't. No, only the ones in the transition metal or the big space in between right down here can have it. All right.